Everybody, welcome back to another fun and exciting Algebra 1 class. Today we'll be talking about parallel and perpendicular lines, and this is found on page 113 in your book, page 113. Let's go ahead and look over there. This is lesson 3.7. What is a parallel line? What is a perpendicular line? Well, parallel lines are lines that never cross each other. Okay, if you look at the little diagram they have there, you have a green line and a purple line, and they will never cross each other. They will never touch. Okay, so now what we're doing is we're putting a second line on the same graph. So here we have our piece of graph paper, and what we've been doing in the past is just one line on that graph paper. Well, now what if we put two lines on the graph paper? Well, there's really only three things that can happen. So, one of the things that can happen is you have the parallel lines, okay, that never touch each other. Another thing is that you have lines that touch each other like a T. All right. It would be like 90-degree angles on all four of the corners. So it looks like these lines come together like a perfect T. And it doesn't matter which direction they are, as long as it doesn't have to look like a T. It could be an upside down T. It could be a T that's kind of on the side or on the edge. Or you could have lines that cross each other in different ways, not like a T, kind of more like an X that cross each other just a little bit differently. So those are really your three options. So in this lesson, we're going to focus on the parallel lines, okay, the ones that never touch, and then the perpendicular lines, the ones that touch like a T. We also will kind of hit on the ones that are neither, but those are kind of the ones that just, if they're not parallel, if they're not perpendicular, then they're neither. They would fall into that category. All right, let's look over here on my screen. All right, so if two lines are parallel, then there's something that is true of them, and that is their slopes are equal. That's super important. So parallel, this is the little sign for parallel right here, which is just like two little straight lines up and down. So if two lines are parallel, they never cross, then their slopes are equal. That makes sense, right? Because their slope is the same. Whichever way they're going, they're going the same direction. They're never going to cross each other. Okay. Now, with two perpendicular lines, and this is the little sign for perpendicular, it's like an upside down T. Okay, so upside down T, that's the sign for perpendicular. If two lines are perpendicular, then check this out. Their slopes are negative reciprocals of each other. Ooh, what's a negative reciprocal? Well, if your slope is 3 over 4, the negative reciprocal of 3 over 4 would be, okay, what's negative? So you just turn the positive to negative. So it'd be negative, and then you flip your fraction upside down. So 4 over 3. So these two lines, if the first line equals, so if slope 1 equals that, and slope 2 equals this, these two lines would be perpendicular. Okay, so negative reciprocal. Flip the fraction, put a negative sign with it. Now, what if it was already negative? So what if my slope was negative 1/2? And that's what we're starting with, negative 1/2. Okay, we do the same thing. The negative of a negative is actually a positive. You don't have to write the sign, but I'm going to here just to show it to you. And then we would flip it 2 over 1. So instead of writing positive 2 over 1, whenever we write something with a denominator of 1, then it's just, you could just write this as the number 2. Okay. So the negative reciprocal of 1/2 is 2. Flip the fraction and then change the sign. So this is what I was talking about just a little bit earlier. Lines can be parallel, perpendicular, or neither. So here is your parallel lines. So in this one, your slope would equal your slope. The slope of this line equals the slope of this line. Okay? Slope equals slope. On this one here, this is your perpendicular line. So remember that the slope is going to equal the negative inverse. What's the inverse of m? So this would be m over 1, right? Because anything over 1 equals itself, so m over 1. So the inverse would be 1 over m, okay? And then this one is where the slope does not equal the slope. It also does not equal the inverse slope. Because think about it. If this is true, then it's perpendicular. Then it's parallel, excuse me. If this is true, then it's perpendicular. So if this is true, then it cannot be parallel and it cannot be perpendicular. It must be something else. So then this one would be that the slope cannot equal itself, and then the slope cannot equal the negative inverse. Okay, and I've kind of got that written here. I would, if I was you, I would write this down somewhere right here. So parallel lines, m equals m. The two slopes are identical, whichever way you're going. Okay, in perpendicular, the m of the first line, the slope of the first line, equals the negative inverse or the negative reciprocal, flip the fraction, of the second line. And then when they're neither, when they're just kind of any direction, but they're crossing, then it would be that slope does not equal the slope, and the slope does not equal the inverse. All right, so on page 114, we're going to do some of these now together. So it says that line 1 is x plus 3y equals negative 2. And then line 2 is 3x minus y equals negative 1. Okay. And now what they want you to do is they want you to say, is this parallel, perpendicular, or neither? Okay. So I'll just write this over here. So the question is parallel, perpendicular, or neither. Okay. That's what it wants us to answer. Which one of these is it? Parallel, perpendicular, or neither? How do we figure that out? Well, we need to know what, let's call it M1 equals and what M2 equals. That's what we have to determine. Once we figure that out, then we can go back up here and say, okay, is M1 equal to M2? Okay, then it's parallel. Is M1 equal to the negative inverse of M1? Then it's perpendicular. Is M2 neither one of those? Then it would be just a crossing line and it would be a neither. All right, so here we go. Let's go ahead and change our color real quick so you can follow along. So here we go, line number 1. So what's the slope of line 1? Well, let's figure it out. We're not in slope-intercept form, so we need to do that. So x plus 3y equals negative 2. What's our slope-intercept form? Y equals mx plus b. That's what we're going for. Y equals mx plus b. Okay, so we want to get this into that format. How do we do that? This is a previous lesson again. We want to get the y by itself, so we need to move the x to the other side. So subtract x from both sides, and we get 3y equals minus x minus 2. Okay, now we're getting close, but now we need to divide everything by 3. And now we're going to get y equals, and we're going to get, this is a 1x, there's always a 1 in front of that, so negative 1/3 x minus 2 divided by 2, so that's going to be minus 2/3. And that really doesn't matter. This is the only thing that we're worried about because this is our m. Okay, so this is m1. Our m1 is going to be negative 1/3. Now we need to go back through and do the same thing with line 2. All right, so I've got everything erased, and now we're going to do the same thing with line number 2. What do you mean same thing? Find the slope, just like we did with line number 1. 3x minus y equals -1. All right, so again, we want to move this to the other side, so we're going to get minus y equals, and we're going to subtract 3x from both sides. -3x minus 1. This is not standard form, so we need to divide everything by -1. Okay? Basically, all we're doing is changing all of the signs. That's going to cancel. We're going to get y equals, and then this sign's going to cancel, and we're going to get 3 over 1, or just 3x, and then we're going to get -1, so that's going to change to a +1. The only thing that we're concerned about is this right here, so we have a +3 in that spot. Now, let's answer this question. The question is it parallel? Is it perpendicular? Or is it neither? Okay, that's our question. So which one is it? Well, it's obviously not equal, so we know it's not this one. It could be neither, but it also could be the negative inverse, because look, we have negative, because remember this up here, the negative inverse, negative flip. So what we want to do is we want to flip this fraction. So if we take this, it's a positive, and if we flip the fraction, it's 3 over 1, which equals 3. Again, we are on page number 114 in your book. You should be following along. And this is letter B in your book. So this is the second example. And they give us 2 lines, but these 2 lines are done just a little bit differently this time. These lines, they don't actually give you the y-intercept. They give you what points they go through. So what we need to do first is we need to find the slope. Remember, the thing that's important is the slope. So if we come over here, we're going to put the slope of line 1 and then the slope of line number 2. These are the important things that we're looking at. So how do we find slope if we don't have it in y-intercept? Remember, because in y-intercept, it's y equals mx plus b. So if we find the m, we found the slope. Well, in this, we would just use our point slope formula. So that point slope formula, we could call these point 1s, and then we call this point 2. So how do we find the slope of a line when we have 2 points? Remember, it's the change in y over the change in x. So we're going to take our 2 points. So the formula says y2, so that's this one right here. y2 is 2 minus y1, which is this one right here, minus, and we'll change that in a second. So the x2 is -1, and then minus, and then the x1 is 3. So 2 minus 1, how do you do that? Change the sign of the second and add. So that's going to give us 3 over, same thing here, signs are different. We're subtracting, change the sign of the second and add. So that's going to be a -4. So our slope for the first line, okay, which is the one that we're working on right now, is our m1, our slope is -3 over 4. -3 over 4. Okay. Now we'll do the same thing with our second line. Change the color here so you could see it. And we have, we'll use these points. So point 1 and point 2. Okay. So same exact thing, only now we're using the second line. So we'll do the same thing. We'll go point 2 is going to be our y2 is 3 minus our point 1. The y point is 0 over. And then our x point is going to be, our x2 is going to be 2 minus 6. And that's going to equal 3 minus 0. I have 3 and I have to take away 0. It's 3. All right, and then if I have 2 minus 3, then that gives me -4. Okay, and remember, we could change the sign of the second and add. You're going to follow the rules of addition, subtract, keep the sign of the largest. Okay, hopefully you remember that. All right, so there we go. That's our second slope. and it is minus 3 over 4. Well, check out what we got. We have matching slopes, equal slopes. What does that mean? You go back up to here to this, and it means that it's parallel because the slopes are matching, the slopes are equal. Okay, real quick, jump over here to your book, page 114. Let's look at C here in the book. I'm not really going to take time to do it on the screen, but notice line 1 looks like it probably never crosses with line 2. And so you might just assume, hey, those must be parallel lines. But notice if you actually do the points and you plug those in, you will come up with one slope is negative 3 over 5, and then the other slope is negative 2 over 3. So those are not the same. Okay, so they don't equal each other, and they're also not negative reciprocals of each other. So in other words, it's not just like you add a negative sign and flip it. So they're not the same and they're not negative reciprocals. So you know what that means? They're neither. They will cross if you keep running those lines like up forever, okay? So if they're going up, and at some point those lines are going to cross each other. Now it might be up, you might need like 20 pieces of paper connected before you're actually going to see those two lines cross each other, but those two lines will cross each other. Notice that there's arrows on these lines, meaning that those lines go up indefinitely in those directions. So they do cross each other. How do we know that? Because we checked the slope, and the slopes do not match, and the slopes are not negative reciprocals. So that's how we know that those will touch somewhere. Those will meet up somewhere. All right, last thing that we want to do is find the equation of the line that passes through point 1, 2, and is parallel to or perpendicular to this line. So we're going to have to do this one together here on my screen, but we can just kind of look through it first. So the first thing that we want to do is we want to find out, okay, what are we actually, what's going on here? So let's reread it and see if we can determine what's kind of going on in this question. Find the equation of the line that passes through point 1, 2. So in other words, they want us to create a new line, and that new line is going to pass through point 1, 2. And the first part of the question is that it's parallel to this line. The second part of the question, the B part of the question, is that it's perpendicular to this line. In other words, we need to create a new equation that matches with this point. And it is 3x plus 4y equals 8. Okay. I would suggest getting this into slope-intercept form. That way we can know what our slope is, because that's really important to answering this question. So what we want to do is we want to kind of move the 3x over here. We've already been doing this, so minus 3x, and that's going to give us 4y equals negative 3x, and then plus 8, because it's a positive 8. So I should have put a minus 3y right there, or 3x. All right, next thing that we need to do is we need to get the 4 over to the other side. So how are we going to do that? We're going to divide everything by 4. Cancel. Y equals negative 3/4 x. That's our slope. That's what we're looking for. Plus 2. All right. And so there we go. This is our slope. That's the important thing. So minus 3 over 4. So now our parallel line is we want to create out of this. Okay, and we should be able to do this. Do you remember how to plug that into the formula? Well, our formula for this, let me kind of change my color here so you can see this as we work through it. Our formula for this from last lesson is going to be the y minus y1 equals our slope times our x minus our x1. All right, so I want to add all my new information in here. And so my point that I want to use is this new point. And so the new point is going to be 1 is my x and 2 is my y. So y minus 2 equals our slope negative 3 over 4 times our x minus our x1, which is 1. All right, so there we go. And now I'm just going to, remember, this is the last lesson. You need to make sure you're always remembering the different lessons. So y minus 2 equals negative 3/4 x. Minus minus is going to give us a plus, and we have to do this. Multiply this 1 over 1, basically. And so it's just going to be the same thing, plus 3 over 4. And then we're going to add our 2 to both sides. And that's going to give us y equals negative 3/4 x plus, there's a couple different ways that you can do this. I would rather you not do it in a mixed number. So the way to do that would be to, when you add, I mean, you could add it 2 and 3/4, but it's better to leave it as a fraction. So you would do the 4 times 2 is 8, and then the plus 3 is going to be 11/4. So that would be 11/4. So this would be our first equation. That would be our parallel equation. So I don't know how I would write that. I would probably write this as our parallel line right here. So the parallel one equals this right here. So you might think, wow, that's a lot of work just to get that. You're right, it is. And we're going to do the same thing now, except for now we need to take this right here and we need to do it with the same point, 1, 2, because that's the point we're given. And we need to do it with our new slope. What's our new slope? So this, remember, this was our parallel. This one is going to be our perpendicular. It's not a perfect T right there. It's terrible. All right, there we go. So this one is going to be our perpendicular. And so what was our slope for our perpendicular? It's the negative inverse. So we would have, since we have a negative 3/4, we would have a positive 4 over 3. So this is our slope for our perpendicular line. We're going to do the same thing, but now we're using our information from our perpendicular. Okay. All right. So let's go ahead and do that. Same information. We're going to plug in our y minus y1 equals our slope times our x minus our x1. Okay, so y minus, again, we're using the same point, so our y is still 2, equals our m, which is changed. Now it's 4 over 3 positive times x minus 1. Okay, and then we just work that equation right there. How do we do that? We first of all start by distributing. Y minus 2 equals 4 over 3x minus 1, which in this case, since we have a positive here, it doesn't change it. So it would stay minus 4 over 3. And then we're going to add 2 to both sides. That's going to cancel. We're going to get y equals 4 over 3x. And then this one's a little bit more complicated over here. And you could do it, I would do it like this. I would convert the 2 to thirds. And so when you do that, you're going to have 3/3 basic, or you're going to have 6/3. 2 equals 6 over 3. I did that because I wanted it to be in thirds because I have to subtract it. So 6 over 3 minus 4 over 3 is going to give us 2 over 3. And that 2/3, is it going to be positive or negative? Well, remember, when you're subtracting, you take the sign of the largest, so that's going to be a positive 2/3. So plus 2 over 3. And this one is going to be our parallel, or our perpendicular. Okay, so our perpendicular is then going to equal y equals 4 over 3x plus 2/3. And that is all in your book as well. And again, all we're doing here, none of that was new, what we just did. Is it a lot of information? Yes, but we're cramming in information from other chapters and we're putting it all into one place. All right. That's all I've got for you. If you missed anything, make sure to slide it back, watch it again. We'll see you later. Have a good one. Bye bye.